Hello everyone. So let's start on some practice questions on chemical thermodynamics. So let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is our index slide and we will see today some practice questions from question number 1 to question number 20. So let's start from question number 1. Which of the following statement is correct? Options are: the presence of reacting species in a covered beaker is an example of open system. There is an exchange of energy as well as matter between the system and the surroundings in a closed system. The presence of reactants in a closed vessel made up of copper is an example of closed system. The presence of reactants in a thermoflask or any other closed insulated vessel is an example of a closed system. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. That is, the presence of reactants in a closed vessel made up of copper is an example of a closed system. How? So for a closed vessel made up of copper, no matter can exchange between the system and the surrounding, but energy exchange can occur through its walls. So it is a example of closed system. Hence option C will be the correct answer. Moving on to question number 2. The pressure volume work for an ideal gas can be calculated by using the expression W, that is work equals to minus integration V initial to V final external pressure into dV. The work can also be calculated from PV plot by using the area under the curve within the specified limits. When an ideal gas is compressed reversibly or irreversibly from volume V initial to V final, choose the correct options. Options are V W work done reversible equals to work done irreversible. Work done reversible is less than work done irreversible. Work done reversible is greater than work done irreversible. Or work done is equal to work done irreversible plus external pressure into del V. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. These are the graphs given here for irreversible and reversible compression. And on the y-axis we have pressure, on the x-axis we have increasing volume. So as you can see, the area under the curve is more in the irreversible compression than the area under the curve of reversible compression. Thus, the work done in the irreversible process will be greater than the work done in the reversible process. Hence, option B will be the correct answer. Moving on to question number 3. An ideal gas expands in volume from 10 to the power minus 3 meter cubic to 10 to the power minus 2 meter cubic at 300 Kelvin against a constant pressure of 10 to the power 5 Newton per meter square. The work done is, options are minus 900 joule, minus 900 kilojoule, 270 kilojoule, 900 kilojoule. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. So work done due to the change in volume against constant pressure is given by work done equals to minus P multiplied by the change in volumes. So on putting the values in this equation with its units, we are getting the work done equals to minus 900 Newton meter, which is minus 900 joule. Hence option A will be the correct answer. Moving on to question number 4. When 1 mole of a gas is heated at constant volume, Temperature is raised from 298 Kelvin to 308 Kelvin. Heat supplied to the gas is 500 joule. Then which statement is correct? Options are Q will be equal to minus of work done equal to 500 joule and del E will be equal to 0. Q equals to W equals to 500 joule and del E equals to 0. Q equals to del E equals to 500 joule and work done equals to 0. Del E equals to 0, Q equals to W equals to minus 500 joule. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. At constant volume, P del V will be equal to 0 because there is no change in volume. Therefore, work done will be 0. And from the first law of thermodynamics, del E equals to Q plus W. So Q will be equal to minus of E, which is 500 joule. Hence, option C is the correct answer. Moving on to question number 5. In an adiabatic process, no transfer of heat takes place between system and surroundings. Choose the correct option for free expansion of an ideal gas under adiabatic conditions from the following. A option is Q equals to 0, del T is not equal to 0, but work is 0. Q not equal to 0, del T is 0 and work is 0. Q is equals to 0, del T equals to 0 and work done equals to 0. Q equals to 0, del T is less than 0 and work done is not equal to 0. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. In the free expansion, work is 0, while in adiabatic process, Q, that is heat, is 0. Del U equals to Q plus W. So since both the terms are 0, so del U will become 0. And del U is also equal to NCV del T. And if del U equals to 0, that this suggests that internal energy remains constant. Therefore, del T will be 0. So expansion of an ideal gas under adiabatic conditions in a vacuum leads to no absorption or evolution of heat. Thus, no external work is done for the separation of gaseous molecules. Hence, option C will be the correct answer. Moving on to question number 6. 1 mole of an ideal gas at 300 Kelvin is expanded isothermally from an initial volume of 1 liter to 10 liter. The del E or change in internal energy for this process is R is given and options are 270 calorie, 0, 10 liter atmosphere or 181.7 calorie. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. So for isothermal process, change in the temperature is equals to 0. Then the change in internal energy, that is del E, for this isothermal expansion will also be 0 calorie. So therefore, del E will be 0. Hence option B, that is 0, is the correct answer for this question. Moving on to question number 7. Del U is equal to, options are isochoric work, isobaric work, adiabatic work, isothermal work. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. So we know that according to the first law of thermodynamics, change in the internal energy is equals to the sum of work done and heat. And work done can also be written as minus P del V. So in the isochoric process, change in the volume is 0. So del U will become equal to Q. In isobaric process, del P equals to 0. So del U will become Q. In adiabatic process, Q equals to 0. So del U will become W, that is work. And in isothermal process, del T equals to 0 and del U will become 0. Therefore, del U is equal to the adiabatic work here, right? Therefore, option C is the correct answer. Moving to question number 8. A piston filled with 0.04 mole of an ideal gas expands reversibly from 50 milliliter to 375 milliliter at a constant temperature of 37 degrees Celsius. As it does so, it absorbs 208 joule of heat. The value of Q and W for the process will be given R value and Ln 7.5 value. Options are Q is minus 208 joule and work is minus 208 joule. Q is minus 208 joule, work is plus 208 joule. Q is plus 208 joule and work is also plus 208 joule. Q is plus 208 joule but work is minus 208 joule. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option D. So as the process is carrying out at constant temperature, therefore this type of expansion is isothermal reversible expansion, for which del U will become 0. Hence Q will become minus W because del U we know that will be equal to Q plus W, heat plus work. That is, heat absorbed by the system is equal to work done by the system, right? Thus Q will be equal to plus of 208 joule and work done will be equal to minus of 208 joule. So we have to keep in mind the sign convention here and then we can get the answer. Hence option D will be the correct answer. Moving on to question number 9. Latent heat of vaporization of a liquid at 500 Kelvin and 1 atmosphere pressure is 10 kilocalorie per mole. What will be the change in internal energy of 3 moles of liquid at same temperature? Options are 30 kilocalorie, minus 54 kilocalorie, 27 kilocalorie and 50 kilocalorie. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. We know that del H is equals to del E plus del Ng RT. And we have given the value of del H, that is 10 kilocalorie for 1 mole. So del H for 3 moles will be 3 multiplied by 10 kilocalorie per mole will be 30 kilocalorie. And R is equals to 2 calorie per Kelvin mole and del Ng is 3 as given in the question. And because liquid is going to vapor, we will put the values in this equation, that is 30 equals to del E plus 3 multiplied by 2 multiplied by 500, and as we have to convert the calorie in kilocalorie, so we have to multiply by 10 to the power minus 3. So del E, that is change in internal energy, is coming out as 27 kilocalorie. Hence option C will be the correct answer. Moving on to question number 10. Del H minus del E for the formation of carbon monoxide from its elements at 298 Kelvin is. The value of R is given. Options are minus 2477.57 joule mole inverse, 2477.57 joule mole inverse, minus 1238.78 joule mole inverse, or 1238.78 joule mole inverse. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. Since carbon and from half of O2 molecule CO, that is carbon monoxide, is forming, so change in the number of moles of reactants in the product is half. So del H minus del E will be equal to del Ng RT. And on putting the values, del Ng is half, R is 8.314 and T is 298 Kelvin. We are getting the del H minus del E will be 1238.78 joule mole inverse. Hence option D is the correct answer. Moving on to question number 11. Consider the reaction N2 plus 3H2 will give 2NH3 carried out at constant temperature and pressure. If del H and del E are the enthalpy and internal energy changes for the reaction, which of the following expressions is true? Options are del H is greater than del E, del H is less than del E, del H is equal to del E, or del H equals to 0. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. So according to the relationship of del H and del H equals to del E plus del Ng RT, where del H is enthalpy change at the constant pressure, del E is internal energy change at constant volume, and we have given a reaction is exothermic. So del Ng is moles of gaseous products minus moles of gaseous reactants. And for the reaction, N2 plus 3H2 will give you 2NH3. Del Ng is 2 or minus 2. 2 minus 3 plus 1, 4 will be equal to minus 2. Thus, del H will be minus E. Del H will be del E minus 2 of RT. And since del E minus 2 RT, that is, something is subtracted from del E. So del H will be less than del E, and numerical value of del H less than del E in exothermic reaction when del Ng is less than 0, right? So question number 12, the combustion of benzene gives CO2 and H2O. Given that heat of combustion of benzene at constant volume is minus 3263.9 kilojoule per mole at 25 degrees Celsius, heat of combustion of benzene at constant pressure will be, value of R is given. So options are 4152.6, 452.46, 3260, 3267.6. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option will be D option. So del H equals to del U plus del Ng RT at constant pressure, where del H is heat of combustion at constant pressure, del U is heat of constant volume, and del Ng will be change in the number of moles in gaseous state. And R is gas constant and T is temperature. So from the equation this, which is given in the reaction question also, so thus benzene is giving CO2 and H2 on combustion. So the change in the number of gaseous molecules del Ng will be 6 minus 15 by 2, that is minus 1.5, and given T is 25 degrees Celsius. So del U is given as minus 3263.9, and which temperature is given as 25 degrees Celsius. On converting to Kelvin, we have 273 plus 225, it will be 298 Kelvin, and R is 8.314 joule Kelvin inverse mole inverse, equal to 273 plus 25, right? And so del of H will be equal to, on putting the values of del U and del Ng and R and T, we have del HP equals to minus 3267.6 kilojoule per mole. Hence option D will be the correct answer. Moving to question 13. Heat required to raise the temperature of 1 mole of a substance by 1 degree Celsius is called specific heat, molar heat capacity, water equivalent, specific gravity. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. The amount of heat required to raise the temperature of 1 mole of substance through 1 degree Celsius is called molar heat capacity, and it is given as C equals to Q divided by N times change of temperature. So option B is the correct answer. Moving on to question 14. The molar heat capacity of water at constant pressure is 75 joule Kelvin inverse mole inverse. When 1 kilojoule of heat is supplied to 100 gram of water, which is free to expand, the increase in temperature of water is. Options are 1.2 Kelvin, 2.4 Kelvin, 4.8 Kelvin, or 6.8 Kelvin. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. So heat transfer at constant pressure is given as NCP del T. On putting the values, we have del T equals to 2.4 Kelvin. Hence option B is the correct answer. Moving on to question number 15. For 2 moles of an ideal gas, options are Cp minus Cv is 2R, Cp minus Cv is 0, Cp minus Cv is R, or Cp minus Cv is R by 2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. Since it is given that 2 moles of an ideal gas is used, the relation for the molar heat capacity is given as Cp minus Cv equals to Nr. So N will be going to equal to 2. So for 2 moles of an ideal gas, Cp minus Cv will be equal to 2R. Hence option A is the correct answer. Moving to question number 16. The heat of sublimation of iodine is 24 calorie gram inverse at 50 degrees Celsius. If specific heat of solid iodine and its vapors are 0.055 and 0.031 calorie gram inverse, respectively, the heat of sublimation of iodine at 100 degrees Celsius is. So options are 22.8 calorie gram inverse, 25.2 calorie gram inverse, minus 22.8 calorie gram inverse, minus 25.2 calorie gram inverse. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. So using Kirchhoff's equation, we have del Cp equals to change in the enthalpy divided by change in temperature. And we can find out the change in enthalpy equals to Cp times change in the temperature. And on putting the values respectively, we have del H2 will be equal to 22.8 calorie gram inverse. Hence, option A is the correct answer. Okay, moving on to the question number 17. What will be the change of entropy at 298 Kelvin for the reaction in which urea is formed from NH3 and CO2? So this is the reaction given. 2NH3 plus CO2 will give you NH2CO NH2 plus H2. And given the standard entropy of urea and CO2 and NH3 and H2 are these respectively. Options are 200 joule Kelvin inverse mole inverse, minus 35.44 joule Kelvin inverse mole inverse, minus 354.4 joule Kelvin inverse mole inverse, 425.2 joule Kelvin inverse mole inverse. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. So for the given change, del S naught will be equal to summation of moles of product S naught of product minus summation of moles of reactant S naught of reactant. On putting the values respectively in this equation, we have find out the del S naught of reaction is equal to minus 354.4 joule Kelvin inverse mole inverse. Hence, option C is the correct answer for this question. Let's move on to question number 18. 2 moles of an ideal gas at 27 degrees Celsius are expanded reversibly from 2 liter to 20 liter. Find entropy change in calorie per mole Kelvin. Given R value, options are 0, 4, 9.2 and 92. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. Entropy change is given by del S equals to 2.303 nR log V2 by V1. And on putting the values, we have del S equals to 9.2. Hence, option C is the correct answer. Moving on to question number 19. For an isolated system, del E equals to 0. Then, options are del S is 0, del S less than 0, del S greater than 0, and the value of del S cannot be predicted. You have 10 seconds to solve this question. After that, we will see the answer. So the correct answer is option C. For an isolated system, enthalpy change is given as del H equals to del E plus P del V, or T del S equals to del E plus P del V, since del H equals to T del S. But we have given that del E equals to 0. So T del S will become only equal to P del V. So del S will be equal to P del V divided by T, and it will be greater than 0. Hence reaction will be spontaneous. Option C will be the correct answer. Moving on to question number 20. When 1.8 gram of steam at normal boiling point of water is converted into water at same temperature, enthalpy and entropy changes respectively will be. Given we have the enthalpy change of vaporization for water, and options are minus 8.12 kilojoule and 11.89 joule Kelvin inverse, 10.25 kilojoule and 12.95 joule Kelvin inverse, minus 4.08 kilojoule and minus 10.93 joule Kelvin inverse, 10.93 kilojoule and minus 4.08 joule Kelvin inverse. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. So del H for condensation for 1.8 gram of steam will be del H equals to minus del H vaporization multiplied by number of moles. And on putting the value, we have del H equals to minus 4.08 kilojoule. The relationship between del H and del S at equilibrium is del G equals to del H minus T del S. And at equilibrium, del G equals to 0. So at normal boiling point of water, T is 373.15 Kelvin. So del S from this equation will be equal to del H minus T. And on putting the equations and on putting the values in the equation, we have del S equals to 10.93 joule Kelvin inverse. Hence option C is the correct answer. Okay, thank you.